This question is an example of parametric equations. The curve shown in figure 2 has parametric equations x equals sine t, y equals sine of t plus pi over 6. Find an equation of the tangent to the curve at the point where t equals pi over 6. Well, if we're going to find this tangent, first of all we need to know the gradient of the curve at the point we want the tangent, and we also need to know the coordinates of the curve at that point. So let's begin by finding the gradient. We've got x equals sine t, so dx by dt is equal to cos t. We've got y equals sine of t plus pi by 6, so dy by dt is cos of t plus pi by 6. Now dy by dx is equal to dy by dt divided by dx by dt. And that gives us cos t plus pi over 6 divided by cos t. Now we're interested in the gradient when t is equal to pi over 6. So at that time dy by dx is equal to the cosine of pi by 6 plus pi by 6, which is pi over 3, divided by the cosine of pi by 6. Now cos pi by 3 is equal to a half, and cos pi by 6 is root 3 over 2. To divide by that fraction we turn upside down and multiply. The 2's cancel and it leaves 1 over root 3. So the gradient of the curve at the point where we want the tangent is 1 over root 3. We also need the coordinates. So when t is pi over 6, x is equal to sine t, which is sine pi over 6, which is a half. Y is equal to sine pi by 6 plus pi by 6, which is pi by 3, and sine pi by 3 is root 3 over 2. So the point at which we want the tangent has coordinates x is a half and y is root 3 over 2. So let's find the tangent. We do this using y minus y1 equals mx minus x1, where m is the gradient. So we've got y minus the y coordinate root 3 over 2 is equal to m, the gradient we found was 1 over root 3, multiplied by x minus a half. Multiply this equation through by root 3 and we'll get root 3y minus 3 over 2, because the root 3 times the root 3 will give us 3 in the numerator, and that will be equal to x minus a half. If we bring everything to the right hand side, we'll get 0 equals x. Bring the y's across, becomes minus root 3y. Bring the minus 3 over 2 across, and we've got minus a half plus 3 over 2, which is plus 1. And that gives us an equation of the tangent. Move on now to part B of the question. Show that a Cartesian equation of the curve is y equals root 3 over 2x plus a half times the square root of 1 minus x squared. Looks quite a complicated expression. Let's go back to the original definitions of the parametric equations to start with. So we've got x equals sine t and y equals sine t plus pi over 6. Now, what would seem a reasonable place to start would be to expand sine t plus pi by 6. Sine of a plus b is sine a cos b plus cos A sine B. So we can say y is equal to sine t cos pi by 6 plus cos t sine pi by 6. Now we'll put some numbers in. Y is equal to cos pi by 6 is cos 30 degrees is root 3 over 2. So this is root 3 over 2 sine t plus sine pi by 6 is a half. So this is a half cos t. Now I can see that x is sine t. So how does that fit in with where we're trying to go? Well, there's the root 3 over 2x. What about the root 1 minus x squared? Well, if x is sine t, that's 1 minus sine squared t, the square root of that. So looks like what we need to do here is to rewrite cos in terms of sine. So we can say y is equal to root 3 over 2 sine t plus a half times the square root of 1 minus sine squared. Right, cos squared plus sine squared equals 1, so cos squared is 1 minus sine squared, so cos is the square root of 1 minus sine squared. And now it just remains for me to replace the sine t with the x. So this is root 3 over 2x plus a half times the square root of 1 minus x squared. And that gives us the Cartesian equation of the curve, and it completes the question.